We've already looked at dividing radicals briefly, but now we're going to look at it from a different perspective. What if we have a radical in the denominator? Well, a radical expression is not considered to be simplified if it has a radical in the denominator. So, in this particular problem, the very first one, 3 square root 7 divided by 5 square root 2, 3 and 5, you can't simplify there. Square root 7 over square root 2, you can't simplify that either. But there is something that we can do because we cannot have a square root of 2 in the denominator. So what we have to do is create a perfect square in the denominator. And to do that, we are going to multiply the top and the bottom by square root 2. What that does for us, well, in the numerator it gives us 3 square root 14, but in the denominator it gives us 5 square root 4. See how I created a perfect square? Since I've created a perfect square, I can take the square root of that, which is 2, and I have 3 square root 14 over 10. So I'm completely simplified. I no longer have a square root or a radical in the denominator. My square root 14 is completely simplified. So what I did when I multiplied by the square root of 2 over square root of 2, that's the same thing as multiplying by the number 1. Because square root of 2 over square root of 2 is 1. When you think about fractions, when you have the same numerator and denominator, that's equivalent to 1, and 1 times anything doesn't change the value. We're just changing the way it looks. So we've created that perfect square in the denominator so that we could take the square root of it and simplify it and work with it. So here we have two problems, and we're going to work both of them. Let's work with the top one first. We have square root of 8 over square root 50 x squared y. And when I look at this problem, and there's a lot of different ways you can organize your work here. The first thing that jumps out at me is that 8 over 50 can be simplified a little bit. That fraction can be reduced. So I'm going to rewrite this, because if I had just 8 over 50, I know that I can divide both the top and the bottom by 2. So that's going to give me a 4, and that's going to give me 25x squared y. Now I'm going to give everything its own square root, and you can do this, like I said, a lot of different ways. I like to do this. I'm a visual learner, and if I give everything its own little square root, it's easier for me to see what I can and cannot take the square root of. So now I'm left with, well, the square root of 4 is 2, the square root of 25 is 5, the square root of x squared is x, and then I have square root y. So all of a sudden this problem has become much simpler. Now I'm going to rationalize my denominator, which just means get rid of the square root or the radical in the denominator. Since it's square root y, I'm going to multiply the top and the bottom by square root of y. That's going to give me 2 square root y over 5x square root y squared. Now I can take the square root of that y term. So final answer, I have 2 square root y as my numerator, and I have 5x, and the square root of y squared is y. And that is my final answer, 2 square root 5 over 5xy. Now, just like I did in the first one where I reduced my fraction, I can reduce my fraction here as well. 15 and 35, I know that 5 goes into both, so that's going to give me 3, and 35 divided by 5 is 7. So now I can multiply by the square root of 7. numerator and denominator. That's going to give me square root 21 over square root 49. Square root 21 is simplified over square root 49, which is 7. Okay, let's look at this problem. 5 square root 11 over 4 square root 3. I'm going to multiply the top and the bottom. Square root 3. That's going to give me 5 square root 33 over 4 square root 9. So 5 square root 33 over 4, and the square root of 9 is 3. So final answer, 5 square root 33 over 12. Now what happens if you've got a denominator that happens to be a binomial? Well, I'm still going to multiply the top and the bottom. But this time we have to multiply by the conjugate. So the conjugate would be 5 minus square root 3. And you'll see why we multiply by the conjugate as soon as we FOIL this denominator. Because remember, our goal is to get rid of radicals in the denominator. So in my numerator, I just have to distribute. So that's going to give me, let's see here, 2 times 5, so that's 10, minus 2 square root 3. Now when I FOIL the denominator, I'm going to get 25. My outers are 5 and negative square root 3, so negative 5 square root 3. My inners are square root 3 and 5, so plus 5 square root 3. And my last terms would give me a negative square root 9. You'll notice that my middle terms, negative 5 square root 3 plus 5 square root 3, cancel each other out, which is what we want to happen because we want all of our square roots to go away. And the only remaining square root is a perfect square. So now let's simplify and see what we have. I have 10 minus 2 square root 3 over 25 minus the square root of 9 is 3. So 10 minus 2 square root 3 all over 22. One last thing, all of my terms, all 3 terms in my answer so far are divisible by 2, so I can actually factor out a 2 in my numerator. And the reason why I'm factoring that out is because I can cancel that 2 with the 22 in my denominator. So I'm able to reduce or simplify my answer. So 5 square root 3, should be minus, over 11 would be my final rationalized answer. So this second one here, we're not going to multiply it completely, but what you would have to multiply the denominator by would be the conjugate, which is 2 plus square root 5. So you would have to multiply the numerator and the denominator by 2 plus square root 5 in order to continue solving this or simplifying or rationalizing this denominator.